Okay guys, in this video we're going to be practicing using a formula that allows us to find the angle between two vectors, which is, if you're asking me, one of the coolest things that we can actually do with a couple of vectors here. And so what I'm going to do is I'm going to drag this back up here. I'm just going to kind of illustrate for you to begin with here. If we have two vectors, we'll call them u and b. Essentially, when we talk about the angle that is made between u and b, we're talking about kind of this angle that is right here, theta. And so in terms of u and b and this angle between them, the first thing I want to kind of start with is like, what's the biggest this angle can ever be? What's the smallest this angle could ever be? And so really quickly here, what I'm going to do is I'm going to throw out that the biggest the angle could ever be here would be 180 degrees. And so that is to say, if this is u and this is b, I'm going to point out that this would be 180 degrees at biggest, because if I were to say spin this any more, then the angle would pop down here and become the other, I guess, it would go the other way. So to rotate this even further this way and this way and this way, you would have this angle here that is now less than 180 degrees. And so a straight angle is the biggest angle I can ever give you between these two vectors. The smallest angle we can ever give you between these two vectors is, kind of think about this as hands on a clock. If I had, like, say, u here and this was v up here, we would say that this is a 0-degree direction between them. And another really important angle that we like to witness, or at least observe, between two vectors u and b is when they have a right angle. Now certainly they can have angles other than these three types of angles, but we kind of look at it as either being acute, right, same direction, opposite direction, or the only other one that I didn't draw here, which was the obtuse case, which it could be something like this right here. And that's fine. That's fine. Assuming that this top one's the acute one, we'll say that this is the obtuse one right here, and we'll call this u and b. So here's the thing. In terms of all of these different orientations that we can have here amongst our vectors, one thing that I can tell you is that this formula, cosine of the angle between the two vectors, and maybe I should put that in red, involves dot products. And that's the cool thing about this, is because we can tell you that the cosine of this angle between all these vectors that you see right here is always equal to the dot product of the two vectors that are involved with one another, but also over the products of their magnitudes, or a couple of scalars here. And so what this means is, as long as I know the dot product between two vectors and I know their individual lengths, then we could just evaluate for this expression on the right and then work backwards to solve for theta, which means, I guess eventually what we're going to have to do is take the cosine inverse of this entire expression right here. So in terms of the difficulty in finding this expression, oh man, this is like super easy. We just need to find three values and then do a cosine inverse of this. But this is going to be the angle between our vectors here. Okay. So some things that I do want to mention very quickly here, and it pertains to this value that you find inside here, the value of the trig ratio. When we do a cosine inverse, I want everybody to recall that cosine inverse is very valuable when it comes to giving us back an angle between 0 up to, but not including, 180 degrees here. So 180 degrees, 90 degrees, 0 degrees. Cosine inverse is going to give us an angle back between here and here. But knowing what we know about cosine and its values between here and here, let's assume that one of our vectors is always pointing at 0 degrees. If I had another vector that was pointing in the exact same direction right here, essentially what we would see is this: cosine has a value of, well, what do we know about the cosine value here? Of 1. And if I were to have two vectors that were pointing in the exact opposite directions here, that is, the angle between them would be 180 degrees, that would only ever happen if my cosine value has a -1 as a value. So if what's in here is a +1, I can tell you they're facing the same direction. And if what is all this stuff is in here is -1, I can tell you that they're 180 degrees with one another. The one that I would say that is very important to remember is this: if two vectors are 90 degrees or orthogonal to one another, orthogonal 90 degrees, then this value of what's in here is going to be 0. And the thing I want to kind of point out is this: the only time that this entire ratio is 0 is if the dot product is 0. And so it's worth mentioning here, if the u dot v equals 0, then they must be orthogonal, or meet at a right angle here. Okay, so we're going to put this formula to use here and see what we could deduce about these vectors that were given in the first place. But one thing that's important to me is that we always sketch the vectors here. And so really quickly here, let's take a look at 32. I am basically going to sketch what I see, but I know that one of these vectors here terminates at 3, 2. So let me go ahead and get a crude sketch here. Right 3 up 2 would be this vector here, and we are giving this a name. Let's call this u. And u is forming an angle with this vector 4, 0, which terminates right here. And so we can definitely see that it is an acute angle here, theta, that we're after. But these are our two vectors. So what we're going to do is this. We're going to acknowledge that the cosine of the angle theta is equal to u dot v over the magnitude of u times the magnitude of v. But what I'm going to advise us to do first is this. Let's just find somewhere off on the side u dot v, which in this case would be 3, 2 and a dot product with 4, 0. And then we're also going to go find their magnitudes individually or independently. So let's go ahead and start with their dot product here. The dot product would be equal to 3 times 4 plus 2 times, let me try this again, times 0 here. So their dot product, we end up with 12 plus 0, which is 12. Now I'm going to throw a box around that. But what I want to look at next is u and v and their magnitude. So in terms of the magnitude of u, the magnitude of u would be the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. So I'm going to put the square root of 13 here. I'm going to throw a box around it. Now I'm going to go find the magnitude of v, which is probably way easier just because it looks 4 units long. And also because when we find the magnitude of v, we'll throw it up here, we get the square root of 4 squared plus 0 squared. So we really get the square root of 16, which I'm just going to write as 4. So now we're going to piece together this expression here that says that the cosine of whatever the angle is between them is equal to the dot product 12 over their magnitudes multiplied together. We get root 13 times 4. We just need to do a cosine inverse of this, and that's exactly what I'm going to do here. And so we get the cosine inverse of all of this. I'm going to have to be crafty in how I type this into my calculator here. So let's go ahead and do that part now. And so looking at this, you could do it in pieces. Things like I could take 12 divided by, in parentheses, the square root of 13. Now you'll notice that I'll have to, whoops, let me go back here. The square root of, there we go, 13. I'm going to have to put an end parenthesis on that square root. So the square root of 13 times 4, and I'm going to have to put an end parenthesis on this because I want to divide 12 by both of these things multiplied together first. So what I get is this decimal here, and then what I'm going to do is I'm going to take the cosine inverse of that entire last answer. And so something neat happens here. As a matter of fact, we get about 33.7 degree angle. And so the neat thing about this is that's cool. This actually is 33.7 degree angle right here, no doubt. But the other thing that is neat about it is I noticed that when I got my dot product here, I got a positive number. And so something is to be said about positive number here, knowing that the value of cosine is positive in the first quadrant and negative in the second quadrant. We could also look at two vectors that are acute angle to one another have to have a positive value here in the cosine inverse. And so if that's the case, then how would this happen? Well, the neat thing about it is that the magnitudes, since those are links, are always positive. And so the only way this entire ratio can be positive is if the dot product is positive. So if the dot product was positive, and it was, we know we have to get an acute angle between these two vectors, which clearly we will. If the dot product is negative, we must get an obtuse angle between these two vectors here like this. And if the dot product is either 1, -1, or 0, then they're facing the same direction, opposite directions, or orthogonal respectively here. So in terms of finding the angle between two vectors, here's all I need from you guys. Find their dot product and their magnitudes, and then we're going to set up this expression here where the cosine of the angle between them is their dot product over their product of their magnitudes, and just work backwards between them. Make sure you draw a picture first. Cheers.